Hello, welcome to Potential U Education. I'm Alex, one of the tutors here, and I'm joined by Ali, our boss.
Hi, everyone.
And last week we went over network computer security. So all sorts of things from passwords to encryption. And I promise you that next time we will do databases, which is here. So let's hop right into it. What are databases? Databases are a way of storing data. So an example of a famous database you may have seen is IMDB, which is the Internet Movie database. That's owned by Amazon and integrated into Prime Video. So if you have a Prime Video account and you pause one of the shows that you're watching, you'll see here an IMDB logo pop up and all of the information about the actors and what they've been in, even sometimes the music that's on will show to you there.
Amazing. And Alex, so that's a great real world example of a database. But why a database is useful in computer systems?
So it's great having Google Sheets or Excel. It's very quick and it's very efficient. The problem is sometimes we just have such large amounts of data that it doesn't really work. And we want our calls to be as fast as possible and even to automate them. For instance, if you're getting notifications from something, let's say a game that you haven't been on for 5 days, there's not somebody going in and checking the Excel spreadsheet and telling you, they haven't been on in 5 days. Instead, it's an automation, so it can check your data within a database and automatically send you updates or notifications. It's much more efficient than some poor guy having to sit by a laptop. Now we have loads of data, but how can we structure this? So we need to set up what is called a relational database. This is where the data is related to each other, and it makes our data more powerful and less abstract. So here you can see a relational database, and that's great. We're done.
Oh, amazing. How does a relational database actually organize data?
So with a relational database, we have primary keys, foreign keys, and we have attributes. So here we've got orders, and you can see the primary key, PK, is order ID, which is going to be an integer, so a number, and it has to be not null. We can't just give nothing, because then our whole database will collapse and nothing will work. So by creating relationships between entities, we're able to create a more effective database. So a good example of thinking of this is a student has one maths teacher, but one maths teacher has many students, and that way you can create your relationships and make your data less abstract. What does any of this mean? I've just shown you that we're done, but what does any of this actually mean? And why on earth are there images of crow's feet here? Well, the best way to show you this is by actually getting onto some software that we have, which is called drawio.com. It's completely free, links to your Google account. In fact, you don't even have to link to your Google account if you don't want to. It's a great tool for creating databases. And also you can just mess around and learn stuff, which is the best way to do it. So let me show you that very quickly. Here we are, lovely and boring in light mode, unfortunately. But from what we can see here we have the primary key, customer ID, and that's an integer, so a number, it's not null. And then the custom name here is a character, so 50 characters. If your name is 51 characters, you're not allowed onto the database. And you must have a name. Now, why did I show you a picture of crow's feet? What on earth does that have to do with anything? So here is our relationship. Now, our relationship can show you what kind of relation one table has to another, and that's through what's called crow's feet annotation, as here they look a little bit like crow's feet. So here is a one-to-many relationship, or a one-to-many, but it doesn't have to be. You don't have to have anything on this side. That's what the little circle means. So customers can have many orders, or they can have no orders. But an order has to have a customer. So the way that you can read these is customers go all the way down, and they must have either none or loads of different orders. And you can also read them backwards, saying that orders all must belong to one customer. Otherwise, your database wouldn't work very well. So here, if we look down, we have entity relations. And this is a great way of just looking through all of the different things that you've got. So there's zero to many optional. There's one to many to one to one, loads of different options. And it's just a great way to play around. The perfect thing to do is to think about it in your head. How does stuff like this actually work? So a good example of a one-to-one relationship is every capital city must have a country, and every country must have a capital city, and every country must have a flag, and every flag belongs to one country. So if you can think through things like this, then you can sort of understand the relationship side of your databases, and it makes organizing data so much easier, because you don't want to be going back and reverse engineering your databases. That's that's a task just to avoid. Not very fun. Now we know what the crow's feet are for. And again, we've got different types of relationships. So one-to-one, such as the country has capital city. One-to-many, so one customer may have many orders, but orders are only ever going to have one customer. And the one that we also have is a many-to-many relationship. So many students will take many classes, and each class is going to have many students in it. Now, out of all of these, which one sounds the most confusing?
To me, I would say one to many.
One to many? It's difficult to visualize like one thing only. It's hard to like think of them, you know? I think that in terms of understanding, one to many is probably the most like confusing in terms of understanding. And in terms of managing, a many to many is a nightmare.
Sounds like a lot.
Because yeah, I mean, one-to-one, oh, if every relationship could be one-to-one, perfect. Don't have to think about anything else, just one flag, one country, no other like, oh, well, what if they've got the, no. All that we've got is the one-to-one. But as soon as we introduce many variables, which there are unfortunately in the real world, stuff gets very confusing very quickly. Here are our database concepts. We've got a table, got a record, and we've got a field. Courtesy of Microsoft. So the table is a structured collection of related data organized into rows and columns. Hopefully you know what a row and a column is. And then a record is a row of data for a specific subject. And a field is a column of data like an age. So the thing that you can search by.
So just to jump in, Alex, what would be the difference between a table, a record, and a field in a database?
So if we look at this from like the big picture, we can have class 8, and class 8 is all of the pupils in the school. So that's your table is called class 8, and then your record is going to be Ali, and that's you. You're in the database. Now your fields are going to be age, subjects taken, probably your address. If you're at the school, they'd want to know that. Maybe your phone number or your email, just different things about you. So some important database concepts are data types. I'm sure that you guys have come across these already. So stuff like integers, chars, bools, strings, they're pretty bog standard across computer science. And then primary keys, so that's a way that you can refer to a specific record and only that record. And then a foreign key, so a primary key in a different table.
So why does a primary key need to be unique?
So a primary key absolutely must be unique. because if you want to search through lots of data really quickly and make sure that you're referencing the correct record, then your primary key has to not match to anybody else's. A good way to think about this is, if I wanted to phone you, then your primary key is your phone number, because I'm not going to phone you and potentially get through to John up in Manchester, because you don't share your phone number with anybody else. It's just you that has that. So it makes it very easy to quickly reference you just by calling you on the phone, rather than calling you on the phone and saying, hey, which user of the phone number is this? And then going through the list of all the people that have your phone number for some reason.
So that primary key has to be unique to the piece of information. Okay.
Yes, absolutely. So it might be a username. I know that Spotify recently rolled this out, where all of your usernames are just random strings of numbers and letters, which is a bit boring, but I suppose it works. And it would become a foreign key in a leaderboard or something, because that username can be used to reference you within a different table. And that's where the relationships become so powerful, is that you can search through data in multiple tables as long as they're all connected through some sort of relationship. Great. Well, now we've got loads of relationships, but we still don't have a database. So how on earth are these dolphins going to help us? And this dolphin is something called structured query language, so SQL or SQL. And structured query language is used to communicate with the database and also create it. There are loads of different commands, but for GCSE, you've only got to know 10. Lucky you guys. And SQL is a declarative language, unlike C#, which is object-oriented. That means that you can just tell it what you want it to do, and you don't have to think about creating different variables for it to be able to do this. If you can give it an English sentence, then it should be able to create it as long as you use the keywords. The first SQL command that you're going to need is insert into, because if you don't insert into anything, well, then you won't have any data in your table, and then your table is pretty useless if you've got no data in it. You could insert into table name, column 1, column 2, values, value 1, value 2. Very creative, those names. And then the next ones you're going to need in order to get that data back. It's all well and good putting it in there, but if you can't reach it when you're not putting it in, then it's again pretty useless. So select, from, where, order by, ASC and DESC, which is ascending and descending. So select age from classroom where name equals Noah or something. And this will give us the ages of all of the Noahs that are in class. And then commands to edit and delete the data. So update, and you can update table name, set column, column 1, so value 1 condition, column 2 equals value 2, and the where condition. So the where condition is very useful in order to streamline and pipeline exactly what you're looking for, rather than just referencing every table that you have for everything, because the more tables that SQL has to look through, the longer it's going to take for you to get your result. So delete from table name, where, condition, whatever. It's up to you.
And Alex, why is it important to use the where clause carefully when deleting records in SQL?
So whenever you're deleting records in SQL, you have to be incredibly careful, because if you delete with a where clause and you accidentally delete something such as, let's give the class example. So delete from class 7 where age equals 13. And let's say this is like a class of all of the GCSE students. Suddenly you're going to have a real issue, because you've accidentally used the where clause in order to delete everybody whose age is 13, which is the majority of your students. So you want to be incredibly selective with what you're deleting. Otherwise, just even one simple mistype can really mess stuff up. For example, if you had an automation at your school to just delete everybody on the record who's above the age of 19 because they finished school, and you accidentally changed that that 9 to a 0, which is right next to each other on the keyboard, and you own like a primary school and a secondary school, well, suddenly half of your pupils are gone. Like all the people that are above 20, they're still there for no reason in your database, and all of your 10-year-olds have vanished. So yeah, you've got to be very, very careful when you're deleting data.
Caution is important, yeah, especially when you're dealing with very, very valuable or important data. That can be almost catastrophic, I can imagine.
Yeah, exactly. I mean, if you lose all of those bits of data and you haven't got a backup or something, then yeah, what do you do?
And Alex, just before you go to that slide, I have a feeling that a lot of what's in within this lesson and to do with databases seems to be fairly similar and linked to things like cybersecurity, which you talked about in a previous video. Is there quite a few links between cybersecurity and keeping things safe online and databases?
Yeah, absolutely. So I imagine that both me and you have quite a few passwords, right?
Yeah.
We've got Google that makes them, we've got Apple that makes them. Whoever wants to make them, they can make them for us, and we're just going to use them because I don't know, maybe it's an account and you don't really care about it. Now, if we were to store that data just in a database unencrypted, well, it sounds to me that there'd be quite a few issues with that. I mean, anybody that's gotten a hold of that, well, suddenly they're you on that account. And it's important that we use what we learned in encryption in order to make sure that this cannot happen. So if your database is encrypted, adding more layers of cybersecurity, then when they take a look at this, it's just going to be a load of characters and numbers, and no one will know what it's saying. So encryption's incredibly important. Another thing that we haven't talked about yet, but it's a really great lead into, thank you, Ali, is general data protection regulation. Yay, law. So this comes under ethics, which I haven't taught yet, but is a really interesting topic as part of computer science. So you can't store people's data for no reason. If I was to try to sell you a coffee and I wanted some data about you, let's say I wanted your email address so that I could give you coffee notifications when we've got new types of coffee in, or I wanted your date of birth so I could give you a piece of cake on your birthday. These are completely reasonable things to ask for. What wouldn't be reasonable is if I were to ask you, oh, what color's your cat? Well, I don't need this information. I'm just gathering it for the sake of gathering it, which goes against the general data protection regulations, so GDPR. And this can be a huge issue. It's why many companies have cookie policies that you must click accept or only strictly necessary, because they cannot just gather whatever data they want on you. And if they do gather all of that data, then that's quite sensitive information. I mean, somebody having your phone number and even saving your credit card to the internet, I mean, this is data that must be encrypted. Otherwise, just anybody can get it. So yeah, encryption and databases, I mean, they're really linked. So
that's a brilliant explanation. And for anyone listening and watching, when being able to draw those connections between different topics will make life a lot easier when you are trying to study, trying to learn, and understand different concepts, when you can see how things join and link together. And I think that will link on to hopefully another lesson where you go a little bit more into depth, Alex, about data protection and about the different laws, which I'm sure will be important to learn about.
Yeah, absolutely. I mean, great revision techniques are things like mind maps, and through stuff like mind maps, you can just draw a line. I mean, you know that the databases are connected to encryption, and you know that the information on them is important. That's linked to ethics. So, I mean, everything that you learn, it's all connected in some way or another. So if you're constantly thinking about it and trying to link back to different places, then when you're answering the essay questions or even the short answer ones, if you can show that you know loads of different things about all of the different topics that are in computer science, it will really serve you well.
Absolutely. Thank you, Alex.
So with that, are there any more questions?
Well, just thinking from a perspective of a GCSE student getting ready for their exams, of course, wanting to cover databases, what kind of topics, questions should they be mostly focusing on or applying most of their time and attention to?
So one of the topics that pops up that is quite a difficult one if you don't tackle it properly is they will ask you to gather data from a database in your exam. So there are coding questions on SQL specifically, which if you're not aware of, can be quite nerve-wracking. However, they're really nothing to worry about. I mean, if you've done it a few times and you can understand what's going on, then it's especially helpful considering that all of the commands are really in English. So if you go back and take a look at some of these, select age from classroom where name is equal to Noah. I mean, you don't have to have a computer science qualification to understand what that's trying to do. Another very important thing that I have not mentioned is the use of wildcard. So wildcard is where you have no idea what you want to get from the database. And this is, you can substitute this for the word all as well. So the way that you do that is just by using the asterisk, which is above the 8. So here, if I were to say, select asterisk from classroom where name equals Noah, then that's just going to get everything from the classroom where the name is Noah. So that might be the subjects that they take or whether they've got any allergies or stuff like that. I mean, it's a very broad way of getting exactly what you want. And then you can narrow it down from there. I mean, even to just see whether the data that you need is in that table in the first place.
Fantastic. Thank you for that, Alex. And that will be the kind of questions that will, I assume, be taken on the most marks as well.
Yes, yeah.
As they do their exams. Fantastic.
So with all of that, next time we're going to cover networks, which are a lot of fun, a combination of both hardware and software. So really pushing all of computer science together and are incredibly important because otherwise you would not be able to watch this video. So,
fantastic. Yeah. Thank you so much, Alex, for doing this and for teaching us. For anyone watching, I think we'll definitely include some resources on being able to practice with databases. There was a great link that you used today, Alex, as well. And I'm very much looking forward to the next lesson on networks.
Perfect. Thank you very much for being here with me and for asking some great questions. I'm sure that it benefited a lot of the students to hear their own thoughts played out in real time. And I'm looking forward to when we do cover networks.
Brilliant, brilliant. Well, thank you very much, Alex. And thank you to everyone who has watched and listened in. And we'll see you all in the next video.